Hey everybody, today we're going to solve all paths from source to target. Um, I was asked this question or a similar question when I interviewed at Duolingo, and so obviously being asked, and I think it's a good one to know. So, given a directed acyclic graph of n nodes, find all possible paths from node 0 to node n minus 1 and return those paths in any order. The graph is given as follows. The nodes are 0, 1, dot, 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 dot to the last index, and graph of I, so any index of this graph, is a list of all nodes j for which the edge ij exists. So an edge in a graph is basically a connector between a node I and a node j. So basically what it's saying is, in this example, the node at 0 has edges going to node 1 and node 2, right? The node at position 1 has an edge that goes to position 3, right? So it's directed, meaning that it's not, you can't go in both directions on any edge, and it's acyclic, meaning there's no loops. So there's no way that 1 would go back to 0 because 0 already goes to 1. So for this example, right, we start at 0, we want to get to 3, which is the third index, right? And this is the 0th index. So we start at 0 and we go to 3. So if we start at 0, we can go to 1, and then at 1 we can go to 3, and at 3 we're done, right? Or we can go to 2, and at 2 we can go to 3. Once we go to 3, 3 we're done. So that's basically what we want to do. Basically consider all paths. If that path takes us to our answer, then solve that path, add that path to our paths output array. If it doesn't take us to our answer, then we don't add it to our paths output array. And basically we want to just do that process recursively on each node that we come across. So let's look at this. So first things first, if there's no graph, we want to return the number of paths we can take to get there, and there are node paths. So there we go. And then otherwise, if there is a graph, we want to have a recursive function that returns all the paths. So we're going to call it get paths. It's going to take the graph. It is going to take, what will it take? Our start index, which is 0, our target index, which is length of graph minus 1. It's going to take our current path, and it's going to take our paths array. So our current path, the one we're on, and paths, the total eligible paths that we're going to return in our answer. Okay, so it'll be easier once we have names for these. So get paths, take self, the graph, start index, target index, current path, and paths. Cool. And actually, just for naming purposes, I'm going to change this start index to source index, just to match, the name of this question. Cool. So now we have to basically define the base case, right? If our source index is equal to our target index, meaning we've traversed, basically, we have a path, and our path has reached us to the end, meaning our source index is now equal to our target index. There are a couple things we want to do. We want to add this step to our current path, right? So current path.append our source index. We want to add our current path to our correct paths, so current path, right? And we want to return all of our paths so far, right? Now here's where things get a bit trickier. So let's look at the first step of this, right? So the first thing we're going to do is consider the zeroth case, right? So 0 is not equal to our target index because our target index is 3, okay? So what do we want to do? So we say, okay, if there are neighbors, if there are edges leaving a 0, right? We want to consider both of these edges and begin this recursive call on each of them, right? So we could say if our graph at our source index, which is 0, has edges, so we can say this basically, Then we want to say for each of these edges, get their paths, right? So there could be multiple paths further down the road. They could branch off. So for neighbor, or so let's say for neighbor index in graph source index, right? So for each neighbor that's in this array at index 0, we want to say, okay, paths equals self.getPaths on the same graph, right? Our source index is now our neighbor index, right? So now we're at the neighbor, right? Our next iteration, we want to be at 1 and look at all its neighbors. So neighbor index is now our beginning index. Our target index remains the same because we're still trying to get to 3, regardless of what iteration we are on this recursive call. Our current path is going to be our current path plus our source index, right? So far we have no path, and now we've tried 0. So now we want to append 0 to our current path and keep going. And then lastly, our paths, right? Path hasn't changed yet. Okay, once that's basically, this would be calling recursively. So it's kind of like a depth first search where you have, okay, you have the 0th index, try 1. Now you're at 1, try 3. Now you're at 3, you're at the end, return it. Okay, so that ends up being stored in paths. And you do the same thing now on the second iteration of this for loop with 2. You'll say, okay, go to 2. It'll run this from 2. So our path goes 0, then 2. 2 says, okay, go to 3. Now our path is 0, 2, 3. Now we're here. Our source index is 3. Our target index is 3. And we meet this base case, and we return paths. So it ends up popping back up the bubble, and we have paths for each of our neighbors, each of our starting possibilities. So then we can just return our paths because we've done all the iterations for all the different starting points. And then each level down, we're doing all the iterations for each starting position and all their further down the road possibilities. So let's run this to make sure it actually works. Cool. So yeah, we got 0, 1, 3, 0, 2, 3, 0, 1, 3, 0, 2, 3. Now let's try this on an empty graph with one node, and it's, yeah, cool. Let's try it on a graph with no nodes. Cool, it's not even a test case. The number of nodes will be in the range between 2 and 15, so not even a test case. Let's submit. Sweet. So I hope you guys like this. It's very similar to a bunch of questions. You can apply this pattern to questions about graphs, questions about all paths, all the number of paths, the shortest path, and so on. Cool. Thanks, guys. If you thought this was helpful, please like, comment, tell me what I could do better. Anything helps. I really appreciate it. Yeah, happy Saturday.